Hello friends, my name is Mohsin Mullah and I welcome you all to this yet another video lecture on the wiring diagram and schematic diagram representation of motor control circuits. So in my previous video lectures, we have already gone through direct online starter control methods for three-phase induction motor, and as well as we have seen the various types available in that direct online method with the help of, you can say, manual control, automatic control, and when the three-phase motor is supplied by two different sources. So that also we have already covered in my previous video lectures, and today in this video lecture I am going to explain to you about the yet another very important starter method for three-phase induction motor, which is a very popular method in most of the industrial applications, that is wiring diagram of manual operation of Stardelta starter. Okay, so now most of the times what will happen, we do not actually require very large current in the starting of the induction motor. So in direct online method, what had happened actually, when the three-phase supply was connected to the motor, all the three-phase supply voltage directly applied to the motor terminals, because of which directly large amount of current would have been drawn by the motor during the starting period. So because of which usually the torque will be very high, as obviously, but sometimes what is important here, not a very large torque, or you can say not a very large amount of current is necessary, but you can say momentum for the starting of the motor is necessary. Sometimes what will happen when we consider a very large rating of the motor. So what usually will happen, so when it is standstill, in the standstill condition, so there is a very little, you can say, opposition for the flow of current through the stator windings, and suddenly when the motor is put on the voltage, it tries to draw around 7 to 8 times the rated current value. Okay, so if the 7 to 8 times rated current value starts flowing through the windings of the stator, what will happen? So obviously it is going to heat the windings, as well as the insulation provided in the motor is also going to get heated up, and it will lose its properties. So it may even lead to the damage of the induction motor. So therefore it is very essential that we need to consider that starting time, and we need to provide, you can say, method where the starting current is drawn, you can say, to the sustainable capacity, not too very large or not too very small. So that can be achieved with the help of a very simple star to delta starter type of arrangement. So here basically what happens, so we already know that when there is a three-phase supply, so it can be connected in star connection, as well as it can be connected in the delta connection. So when there is a star connection, in that case, so obviously the voltage between the three different phases can be obtained as line to line as well as line to phase. So in case of star operation of the this star delta starter here, so I'll just try to draw the winding diagram and try to explain to you. So suppose if it is connected in the star connection in the beginning, so this is the star connection. Okay, so now there are three ends, say this is A1, A2, okay, similarly B1, B2 and C1, C2. So three ends are available for the connection to the three-phase supply, okay, and the other three ends are connected to a common point, so because of which it forms a star connection. Now if there is a total three-phase voltage available between two lines as say 400 volt, so in that case, if I measure the voltage between one line and phase, it is going to be 230 volt, and depending upon the you can say resistance here by this particular one phase of the stator winding, suppose there is a current flowing here 10 ampere. So if this is 10 ampere current flowing here, suppose if the neutral is not available and directly line to line connection is done, in that case 400 volt will be available between this line and this lines, because of which this current will become, in that case the line to line current will become 30 amperes. So what you can understand here is that, so when we are connecting in the star connection, so in that case the voltage applied gets reduced, so from line to line voltage to single phase voltage, because of which the current is going to reduce to 1/3 of the value that it would flow when it is connected in the line to line connection, which is in case of a delta connection. So now you can see that delta connection, if I try to show you, so let me try to use the same coils and try to show you the connection that is going to happen here. So this is A1 and A2, then from there B1 and B2 will be connected Okay, so delta connection is nothing but end to end connection, so B1 and B2. Then obviously next terminal is from the third winding C1 and C2. Okay, so now when the supply is connected, it will be connected between any two lines, because of which directly 400 volt will be applied, because of which the current drawn will be not 10 ampere but it is going to be 30 ampere if you just take it as a for the sake of example here. So the current may be too large than this actual value what I am considering here. Okay, so this is how you can say the current can be reduced in the beginning, as we are going to consider only phase voltage in the starting, and later once the motor picks up to its near to its rated speed, in that case directly it can be converted to delta connection, and in that case the rated current will flow through the motor as well as the motor will rotate with the rated speed. Okay, so now to make that possible, so we have a arrangement here, manual operation of the star delta starter. So let us try to understand how the connection is formed and how the things are working in you can say in sync with all other parts here, so that we get the operation of star in the beginning, okay, at the time of starting, and delta when it is running. So as obviously we need the three phase supply, so here the three phase lines are provided and the three lines are tapped here. Now there is one particular you can say contactor. Okay, so this is a electromagnetic contactor, and in previous videos we have already seen this many times. So therefore what it is going to do, so when we want to start the motor, we are going to push a green button which is usually a start button. So here that P indicates the start push button. So when I press this start push button, so what will happen, so the supply will be taken from one from this B phase and another one is from this R phase. So this is going to get energized by R and B phase, because of which so these two contacts will get connected and there will be a supply available to the energizing coil A. So because of which the coil A gets energized, acts as electromagnet, and that will operate this electromagnetic contactor to engage the upper terminal to the lower terminal. Now in the lower terminal there is a thermal overload relay connected in series. Also we have seen the operation of this thermal overload relay in the previous video lectures. Now what it is going to do, in case there is a overload condition on the motor, and because of the overload condition large amount of current starts flowing through the motor windings, so that will be sensed by this overload relay, and as the current flowing is larger, so that will make that metallic strip to bend, and because of which there will be disconnection from the one of the phases here, so that other phase is R phase, so that disconnection from that B phase will make the contactor get de-energized. So this is connected in series with the S, and this S is connected to the one terminal of this magnetic contactor. So when this terminal gets disconnected, obviously this is going to get de-energized, and that contactor will release, and you can say the motor gets turned off in case if it is overload condition. So for that purpose it is provided. Now suppose it is working normally, so in that case the motor gets started. So when we have pushed, so the coil is energized, contactors are connected, so here the three phases are available. Now when the switch S is with the help of a handle moved towards that Y connection, so here Y connection will make the other three terminals here. So you can see these ends, whatever these ends are there, so these are going to be connected either in the delta form or in the star form. So in case of a star form, they are going to get connected to this three terminals. So these three terminals are shorted together, providing this neutral point. So if you trace the three terminals, what these three terminals are, these are nothing but the other ends of these three stator coils. Okay, so here you can see the stator coils A2, B2 and C2. So they are connected to the common terminal. And what about the upper terminals? Since this is energized, therefore here R, Y, B as it is, they are available, three phase supply is available, and this three phase supply is connected to the upper ends of this stator windings. Therefore the directly three phase supply is given in the form of a star connection. Okay, so all of these are connected at neutral at one end, and other ends are given with the three phase supply. So this is the star connection. Now the motor starts running. Okay, so it is going to reach to its almost near to the rated speed. So when it reaches to the rated speed, in that case now we can move that switch from Y position to del position. Okay, so when we move the switch S from the Y position to del position, keeping this push button, you can say, pressed, or if even if you release, doesn't make any difference, as this contactor is energized as long as there is a R and B phase connected together, and as long as we want it to be turned off, so there will be a supply available and therefore it will be continuously on, means these three phases are contacted. Only we have to change the position of this S from the Y to del. So when I make this Y to del, what will happen? Now these three ends are going to get connected in the del form. So del form means, if you see here, so these are going to get connected to these ends. Okay, so here, so now if you trace these ends, so like I have explained, so A1 end is going to get connected to A1 to A2, then A2 end is going to get connected to B1. Okay, so if I trace the A2 end, so here is A2 end and it is going to get connected to B1. So here I'll just write this first starting ends are this A1, B1 and C1. Okay, so now A2 is going to get connected to B1. Likewise, B2 is going to get connected to C2. C1. So B2 is going to get connected to C1. So likewise, C2 is going to get connected to A1. So this is the C2. If you trace this C2 is going to get connected to A1. So now you can just see this. That is what is being connected when I put the switch to del mode. So this is what it looks like. Okay, so this is delta formation. Now the three phase is applied in the delta formation. So large amount of current, or you can say 3 times the current of when it was flowing at the time of starting, would flow in the that delta winding, and the motor will be running safely. Okay, so this is the way you can understand the working of this Stardelta starter with the help of the wiring diagram. And even in the examination you need to draw this particular diagram and write a few descriptional words in your own way. Okay, so that will do the necessary part required for the examination. Okay, I hope you are able to understand the working here with the help of the wiring diagram, and you are able to understand how the you can say reduction in the current takes place when we do change from delta to star and star to delta. Okay, so I hope you will continue to watch my video lectures on this wiring diagram and wiring scheme, previous videos as well as the next videos that I am going to do now. So till the next video, happy learning and thank you.